Hi everyone, my name is Damian, and myself, Elena, and Shwetha are the Data Clinic team working on the Internet Equity Initiative project this quarter. The Internet Equity Initiative, or the IEI, is an interdisciplinary research initiative based out of UChicago's Data Science Institute, which aims to produce datasets, toolkits, and actionable research to support communities across the United States working to empower their residents with better internet. Their mission? To realize equitable, resilient, and sustainable internet solutions that benefit all communities and close the digital divide that exists in the US today. To give some motivating statistics for why their work is so important, just in the city of Chicago, more than 100,000 children under the age of 18 lacked access to broadband internet connectivity at the start of the pandemic. During the same time, nearly 1 in 5 teenagers across the whole US said they've been unable to complete homework assignments due to a lack of reliable connection. In 2023, 25% of all US households had no home internet, and 6% said they had no connection to the internet at all. Currently, there are numerous government funding and subsidy programs which are being directed towards providing fast and reliable broadband infrastructure. The way the IEI hopes to achieve their mission goal is by making sure that the relevant stakeholders, i.e. individuals with the power to decide how these programs are carried out, that these individuals all have the most relevant and comprehensive information possible.
The way we want to help IEI further their mission is to understand and analyze geographic patterns of where challenges were successful and where they were not. This is essentially our project goal, and analyzing this data will help us address the larger issue of internet access and broadband connectivity. Our main task is to analyze the data on challenges to determine patterns of participation in the challenge process. Through this, we'd like to identify features that are likely to determine number of challenges and features that are likely to make challenges successful or unsuccessful. We can identify features through a number of ways, including geospatial distribution, examining the relationship between challenges and demographic factors, and pattern analysis within and across states, doing both at the track level as well. To give some more context about our project, let us understand what a challenge is. A challenge is a way to correct inaccuracies in the state's broadband map so that it reflects the most up-to-date broadband access across the state. This updated map will determine which locations are eligible for funding to improve broadband access. There are two main types of challenges. The first is the fixed challenge, which is a challenge to existing information about observed broadband service availability at a location. The second is the fabric challenge, which is a challenge to existing geographic information about a location on the FCC broadband map. For our analysis, we're going to focus on fixed challenges.
Now we will briefly describe the structure of our data. We worked with a complete data frame of 3.7 million fixed availability challenges which were filed across the US. In total, we worked with 25,000 entries at the tract level where challenges were submitted. Our data frames were aggregated by tract, county, and state level and then merged with census demographic data. Now moving on to our analysis. Our first deliverable involved looking at correlations of fixed challenges with census variables to determine the most significant features. Due to the highly correlated nature of our explanatory variables, we conduct factor analysis to determine specific sets of effectful features. After selecting explanatory variables, we ran regression analysis for first, the proportion of challenges upheld, and second, the number of challenges per household across the US. Finally, we created map visualizations to determine geospatial patterns in our data.
As mentioned, we wanted to investigate how the demographic and socioeconomic features of a tract are correlated with the proportion of challenges upheld and the total challenges per household. Initially, we investigated these correlations across all states, after which we chose to focus on correlations within certain states themselves. In particular, we investigated the trends in Illinois, Nebraska, New York, Michigan, California, and Virginia, as these were the states with the highest number of challenges submitted. In the graph on the slide, we can see the largest correlations with the total challenges submitted per household in Illinois. And some notable insights from Illinois were that a higher proportion of white individuals was positively correlated with more challenges per household in the tract, whereas tracts that had higher median incomes, higher housing values, and a greater proportion of non-US citizens correlated with lower challenges per household.
Our factor analysis produced 3 groups of demographic factors that influenced participation in the big challenge process. In other words, neighborhoods with certain characteristics submitted a significantly higher or lower number of challenges than others. The same characteristics influenced the proportion of upheld challenges too. The first group of neighborhoods which demonstrated lower participation had a higher level of education, higher mean housing value, more Asian and foreign-born residents. The second group of neighborhoods which also showed lower participation had a higher share of households below poverty level, more households on SNAP or receiving public assistance, and a higher proportion of Black residents. Finally, the third group, which was identified during factor analysis, showed a higher level of participation. That is, these neighborhoods submitted more challenges and had a higher proportion of upheld challenges. The respective neighborhoods had a higher median age, lower level of education, higher rurality level, and lower proportion of foreign-born residents.
Finally, we'll look at the interactive maps. We'll show a demo that showcases these maps. As you can see, we have 3 variables we can choose from. First is the challenge variable, which includes the proportion of challenges upheld and challenges per household. Second, we can select any state. And third, we can select any relevant census variable for comparison and analysis. After selecting these variables, 2 maps will be produced, one for the challenge variable and one for the census variable at the tract level for that state. And finally, we'll have a scatter plot that shows the relationship between these 2 variables. Our main takeaways from the interactive visualizations are that we can now spatially visualize the correlations and identify tracts that are outliers. It also allows us to see trends and determine where to focus next for our analysis. Our main contributions include being able to determine demographic patterns of challenge distribution through correlation and regression analysis. We were also able to understand geospatial patterns via interactive visualizations, and we created a resource that can be used by others to investigate patterns in the challenge and census data. Our next steps include drilling down further on certain tracts that have a high number of challenges to understand what's driving those numbers, and examining whether tract-related trends also hold at the county level. Thank you.